Problem 6. The Maclaurin series for natural log 1 plus x is given by this alternating series. X minus x squared over 2 plus x cubed over 3 minus x to the fourth over 4 plus etc. And it says on its interval of convergence, this converges to ln of 1 plus x. Let f be the function defined by this, x times ln of x plus x over 3 plus 1. And they want us to write the first four non-zero terms and the general term. So what's happening here? Everywhere that I see an x, I'm replacing with x over 3. So this is going to be x over 3 minus x over 3 squared over 2 plus x over 3 cubed over 3 plus x over 3 to the fourth over 4 plus dot dot dot. And this is still an alternating series. This is going to be x over 3 to the n over n. Now that's just the natural log of 1 plus x over 3. I still need to multiply that times x, so I need to multiply this whole thing times x. So that's going to give me x squared over 3 minus, this is going to be x times x times x, so x cubed over 3 squared times 2. This is going to be x to the fourth over 3 cubed times 3. This was a minus sign, thank you. Minus x to the fifth over 3 to the fourth times 4 plus dot dot dot. And this is going to be negative 1 to the n, x to the n plus 1 over 3 to the n times n. So that's going to be my expression. There are my first four non-zero terms. Of course, there's a 1 there, what I didn't need to write, but it makes it easier to identify the pattern. And so that's part A. On part B, they're asking us to determine the interval of convergence, and probably the easiest thing to do would be to look at the ratio test. In other words, I want to know what's going to happen when I take the look at a sub n plus 1 over a sub n, the limit as n increases without bound. And of course, I really want to know when this is going to be less than 1. Because if that's true, then that means my terms are getting smaller successively. So looking at this from our previous answer, f for us was, f of x was x to the n plus 1, negative 1 to the n plus 1 over 3 to the n times n. So our ratio test, we're looking for the limit as n increases without bound of negative 1 to the n plus 2, because I'm adding 1, times x to the n plus 2 over 3 to the n plus 1 times n plus 1. And this is all divided by, so I'm going to multiply by the reciprocal. I'm going to have negative 1 to the n plus 1, x to the n plus 1, over 3 to the n times n. And of course, because I've got the absolute values, these don't really matter. What matters is this value of x here and this value of x here. So I'm going to have x to the n plus 2 times 3 to the n times n over x to the n plus 1, 3 to the n plus 1 times n plus 1. And I'm looking to see what happens as n increases without bound, and I want this to be less than 1. In other words, I really want this, x over 3, because that's what happens. This limit, of course, is 1. I want to know where this is less than 1. So negative 1 is less than x over 3 is less than 1. So negative 3 is less than x is less than 3. Now I'm looking for the interval of convergence, so I am going to have to check my endpoints. I'm going to see what happens when x is negative 3, and I'm going to see what happens when x equals 3. If x is a negative 3, then I end up with negative 3 to the n plus 2 times 3 to the n times n over 3 to the n plus 1 times n plus 1 times negative 3 to the n plus 1. And so this is n plus 2 plus n, so this is really 2n plus 2 on the top, 2n plus 2 on the bottom, so all of these are going to cancel out, and it's just going to leave me with n over n plus 1 as n increases without bound. Well, this is equal to 1 always, so we do not have equality. And I can use the exact same argument just without minus signs here, but this is not going to be equality as well. When I take that limit as n increases without bound of positive 3 to the n plus 2 times 3 to the n times n over 3 to the n plus 1 times n plus 1 times 3 to the n plus 1, the same thing's going to happen. All of these 3's will divide out, leaving just n over n plus 1 equals 1. So this is, in fact, my true interval of convergence. And this is going to take us to part C. Part C says, let P sub 4 of x be the fourth degree Taylor polynomial for f about x equals 0, using the alternating series error bound to find an upper bound. Keep in mind that if I want to use the alternating series error bound, I need to know two things. One, are we an alternating series? Well, yeah, we are an alternating series because our series has that negative 1 to the n plus 1 part of its term. And two, if I take a look at a sub n plus 1, is a sub n plus 1 always going to be less than or equal to a sub n? And we saw that was happening when we did our ratio test earlier. So this satisfies everything we need for the alternating series test bound. And so I know that P4 of 2 minus f of 2 has got to be strictly less than or equal to my fifth term. So my fifth term is going to be that negative 1 to the 6th times x to the 6th over 3 to the 6th times 6. And I want to know what's happening when x equals 2. So I'm going to have, of course, negative 1 is going to go away because of the absolute value. So this is going to be 2 to the 6th over 3 to the 6th times 6. This is my error bound. And so that's it. That's what we're looking for.